respected conference chair, dear special minds, SSN publications, and dear participants, greetings. Myself, Dr. Manish Sharma, working as faculty in Department of Physics, Punjab University, Chandigarh. Welcome you all in session of sciences. I am working in Department of Physics from last decade. My research area is solid state electronics, and the thrust area is chalcogen materials or chalcogenide glass. Today, in the time of pandemic, we need special diagnosis techniques, especially touch-free diagnosis. So, I am discussing a special technique using chalcogen fibers. It is called fuse. So let's start this discussion with my presentation. The discussion is about the application of chalcogenide fibers for biomedical sensing applications. Starting with the introduction of chalcogenide glasses. First, we will discuss the synthesis of chalcogenide glasses. Then, further synthesis of chalcogenide fibers. Application of these chalcogenide fibers for biomedical applications. And finally, the conclusion about it. What is chalcogenide fibers? Chalcogenide fibers are basically manufactured from chalcogenide glasses. The chalcogenide glasses are compounds containing one or more chalcogen atoms. Means these are from the oxygen family, except oxygen. The basic reason for the versatile use and popularity of chalcogenide glasses, chalcogens, is their special properties like optical properties, electrical properties, as well as thermal properties, and their widespread applications for science and technology era. Secondly, they are transparent in visible region, of course, in infrared region as well, and they are stable in aqueous solutions. So we can say the fibers made up of these glasses are fabricated for diagnosis and detection and analysis of biological species. Sensors which we can make from these fibers are successfully tested, and currently they are used in medical field to find out the detection and imaging of degenerated cells and tissues of the human body. There are various applications for chalcogenide glass fibers. Like I'm presently discussing biomedical applications, but apart from it, we have detection of biological species, gas sensing like leakage of gases from the cylinders, detection of water pollutants like pollution control can be done with the help of chalcogenide fibers. Food degradation, like quality of food with the aging, can be detected with the help of chalcogenide fibers. And of course, detection of foreign elements in foods. This is one of the adulteration application that we can have with the help of chalcogenide glass fibers. So we have multiple application areas open for chalcogenide glass fibers. So starting with the prominent application during this dynamic time is biomedical applications, which I have selected for this keynote address. So how we synthesize single index chalcogen fibers from the glass. Basically, we have solid preform which we place in the muffle furnace inside the laboratory. First of all, we soften the glass due to heating, means a annealing process is used for softening of the glass. This softened glass usually drawn into a fiber of uh, length of few meters and of course uh, diameter in the range of micrometers. It's very thin from length and breadth. So this diagram you can see how the synthesis of double index cellulose fibers from the glass. This technique is called rod in tube technique, where we have the parallel inputs from the core glass and cladding glass. Similarly, just like optical fiber, we have core and cladding. So basically, for both the process, we use ampules. Quartz ampules are used. Those are basically filled and sealed in a vacuum. Then we heat the ampules for core glass and cladding glass. Then for core glass we go for cooling, and similarly for cladding glass we faster spin and cooling basically. The technical point here. So we have a core rod by this, and of course cladding tube. So this is shown here like we have a cladding tubes on the boundary walls and core rod in the center. So by this we have a solid preform as a use for rod and tube technique for double index chalcogenide fiber. So this is a synthesis of double index chalcogenide fibers from the glass for sensitive core cladding casting. Again we have, you can see clearly explained, like both core and cladding are mixed, means merged together. Like here on the top we have input or inlet for cladding material. Similarly on this side we have inlet for core material. So basically cladding casting is of course a better technique to fabricate the chalcogenide fibers, as the core clad interface is better as compared to rod end technique. So see how we have done the biomedical sensing. Basically the technique commercially is called fuse, like fiber wave luminescent spectroscopy. So this is basically senses of biological traces by using fuse. So you can just have a picture here where when the light propagating inside the optical fiber is of same wavelength as of surrounding medium, then the fraction of light is absorbed by the medium, and of course the attenuated signal is oriented at the output end of fiber. So you can see that we have a IR source, infrared source as the input, and similarly detector is connected across it. So the detector is basically reading the data from the sample, and of course we analyze the data and we generate the infrared spectrum. So we can say why this method in this sensing. The chalcogenide fibers, which are transparent in IR range, infrared range, and of course, the most of the biological species from humans emit radiation in IR region, infrared region. So we can say that the chalcogenide fibers are not only used as transmission medium but also as a sensing element in this proposed technology. So of course, we can increase the efficiency of this method. So fuse efficiency can be increased by two or three moderations in this method, like reducing the diameter of sensing zone of the fiber means you should make it more precise, reduce the diameter of that sensing zone, and increasing the number of loops of the sensing zone. You can increase the loops of this means you are basically increasing the sensing area, or you can say you are increasing the probe area for sensing basically. So the last one, quite common, means cleaning of the fiber surface before use, of course, to avoid this contamination of analyte. So that could be one of the method to improve the efficiency. So there are so many other numerous applications from the chalcogenide fibers. Like we can use in shape memory alloy. Shape memory is basically a nitinol wire that we can have one of the type of shape memory alloy that we use in stenting for heart diseases, even the wire that we use for shaping or you can say change the structure of the teeth, like and there are other viral nanomaterials, those we have here. So magnetic nanomaterials that we use for drug delivery, because it becomes nano, and of course efficiency level of the drug increase with this. So these are the basic other biomedical applications or biomedical materials those we have available with us. So finally, the conclusion of our discussion is that these chalcogenide fibers are generally stable in aqueous solution because of their hydrophobic nature. So they are widely used in medical field. The other thing is their optical property, means optical transparency of chalcogenides in IR region is making them the prominent candidate for detection and imaging of biological species which can emit radiation in the IR spectrum. The most common employed spectroscopic technique that I have mentioned is FPWH fuse. Use of chalcogenide fibers has made things easier, as a single fiber is used as a transmission medium and sensing element as a proposed technique. So with the advent of these fiber, we can say it is easy and of course possible to diagnose deadly diseases at early stages. Like nowadays, it's a dynamic time for everyone to come up with ideas to fight with the diseases like COVID-19. So earlier detection can also help medical professionals to decide the easy detection and diagnosis. So finally, I can conclude my presentation. but it will not be justified to acknowledge few uh, personalities, starting with my department of physics, Punjab University. Uh, Sakshi Sani is research scholar, my research scholar in Department of Physics, Punjab University. My collaborator, Dr. Shweta Mohan, assistant professor at PBK DAV College of Research. Of course, last not the least, Dr. B. Balaji, the founder and CEO of Special Mind. Sir, I appreciate your efforts and special thanks for your kind consideration to give me the platform to share the knowledge with the participants. Thank you, sir. So this is all about my discussion on biomedical application for sensing and detection of diseases by using chalcogenic fibers. So apart from this, if you have any query, then you can have a contact with me. My profile is also available on the Google and departmental website. Thank you very much. Uh, Thanks again.